Welcome to the session of fluid mechanics. Today we will discuss about the fundamental concepts of fluid mechanics. Okay, so first of all, while getting into the subject, we should have a basic idea about the origin, about the importance and the application point of view. That is basically the engineering application point of view. So first of all, what I want to say is that the subject fluid mechanics is not uncommon to you. It is quite popular because it is quite familiar to us from our school life. Okay, so the term fluid, if we want to mean it literally, that that the one which can flow. Okay, so technically we can define fluid as a set having liquid plus gases. Okay, so the subject that deals with the fluid, which describes all the physical laws that govern the flow of fluids and ultimately helps us to recognize the cause and effect of flow through determined characteristics parameters like pressure field, velocity field in a flow region, along with other properties like density and viscosity. In a simple word, what I am trying to say is that if any fluid is passing through a region, that is a flow field, where this flow parameters like velocity, pressure, densities are being analyzed by the subject fluid mechanics. It is not that when the fluid is in motion we are analyzing it, when the fluid is in rest we are also analyzing it at the same time. That is fluid statics. Okay. The importance of this subject, what we can say, that if I am giving and citing an example from the basic existence point of view, that we breathe in or breathe out or circulation of blood, these are all depending on the principle of fluid mechanics. That is the principle of fluid flow. Okay. Or we can imagine us living in a ocean of fluid, that is air. Okay, and this air is exerting a pressure on us, and these are all governed by the law of fluid. Okay, or I want to give you another example, that if you if you raise at higher elevation from the sea level, then definitely the pressure gonna decrease, and these are all guided by the fluid mechanics. Okay, that is the laws of fluid flow. Okay, now another thing, I will try to say that from the application point of view, as far as the fluid mechanics is concerned. Okay, while thinking that this fluid mechanics is applied on engineering application in many ways, that is sprinkling water in gardens or many other places also, transportation of fluid through pipes from one region to another region. The fluid mechanics concepts are used in propulsion of rockets and hydraulic jacks, and there are many applications, innumerable applications where this fluid mechanics is applied. Okay, so definitely this fluid mechanics is basically can be treated as a classical subject like physics. Okay, because from the origin, the Archimedes, the discovery of Archimedes principle, the concept of buoyancy, and later what Newton, Lagrange, Euler, Rayleigh made contribution based on natural observations. Okay, but laterwards, many scientists pointed out that fluid mechanics cannot be incorporated by analytical theory only, because that actually this indicates that there was a widening of experiments and theory. So the engineers carry out different experiments to find out empirical rules of fluid. Okay, so from that the birth of hydraulics came up. Okay, so this is a very popular thing, that hydraulics, we all have heard about it. So later on in 90s, Prandtl and Taylor, they also developed this fluid mechanics with the help of advanced mathematical theories, and the day to day the fluid mechanics has improved, and now in this 20th century, what we can say, that the coming of computational methods by which this analysis of fluid flow has become much more easier, and this has become the burning topic and the popular topic of discussion in today's world in fluid mechanics. Okay, so this is all what I have to say about the introduction about the fluid mechanics. Now, the basic idea now we're gonna shift is that what is fluid? Okay, so as we appreciated that matter basically consists of two broad classes. One is solids, another is fluid. Okay, so now if you want to differentiate solid and fluid, then what are the parameters by which it can be differentiated? The parameters or the differences that we studied already was basically based on molecular arrangement or the intermolecular forces. Okay, and now what we're going to analyze is based on mechanics. Okay, that means a force should be applied on the matter, and that will indicate its behavior. Okay, so definitely what we can analyze that we are considering the first case of a solid. Okay, so we are considering a solid which is basically connected by a rigid support like this, and we are applying a shear force, that is a tangential force, to the surface. Okay, and due to application of this force, this parallel force, the shape of this body changes. Okay, due to application of this shear force, the body undergoes static deformation. Okay, because at some time this body will be in equilibrium after certain deformations. Okay, now this after withdrawing the force, it can regain or partly regain its original size. Okay, or initial form. Okay, so rather if you want to differentiate with a fluid, okay, on the other hand, so this is a fluid which is flowing in a region, and if we consider a small part of it, okay, and now upon which a shear force is acting, there is a tangential force which is acting to the surface. Okay, now what we can say is that due to application of this shear force, what we are seeing is that the body, that this fluid is continuously deforming from 1 to 2, from 2 to 3. Okay, and same thing for here, it will be like this 1, it will be 2, and same thing it will be for 3. That means for a fluid, due to application of this shear force, there is continuous deformation of the body. Okay, so it is clear that it can resist only tangential stress at the dynamic condition, not in the static condition. Okay, but another thing is that in case of a fluid, there is a memory loss. Okay, we can say it like this, because after we are deforming it, it is not recovered at all. Okay, but in case of a solid, there is a chance of recovery. Okay, there is another part of fluid which is not beyond the scope of this part that can recover, and that has an elastic property, that is viscoelastic fluid. Okay, but mostly what we can say is that fluid does not recover. Okay, so another part that we can relate this stress and strain in case of a solid with the help of an constitutive relation, that is the material property, or the material property by which we are relating stress and strain, okay, for a solid. But in case of an fluid, what we can say is that the geometry what we are seeing in case of a fluid is basically changing with respect to time. So the stress cannot be the sole function of strain only. It will be a function of strain rate. because with respect to time, the body is continuously deforming. Okay, but in case of a solid, what we can say that it is having a static deformation, and it is the constitutive relation that we are getting is not in the form of time parameter. Okay, so another thing what we conclude from this above idea, that solid is basically the matter where we apply a tangential force to the surface, there will be a static deformation. But in case of a fluid, if we apply a shear force to the surface, it will continuously deform. Okay, these are the basic difference between solid and fluid with respect to from the mechanics point of view. Okay.